stellar object.
Another thing that I thought at some point is like, could it be, I know that this is crazy, but could it have been ejected from the solar system, and then could we, I mean, could there be like a cloud of things ejected and we just encounter it on the way back? I mean, when we do a galactic, you know, probably not, right? Because I think we'll.
Well, what do you mean? I mean, things ejected from us would have the same velocity as us moving to the galaxy.
Yeah,
plus the
plus whatever.
But it's not like we're moving, ejecting, and then we're moving through.
I mean, are there other sources of these objects that we're just not aware of? Right?
There has to be, right? There has to be. Maybe. I mean, there is this. There were several suggestions, right? That it might be coming also from an evolved star, or you know, Avi and Samuel had a very interesting idea, right, of it being a solar cell, right? I have another crazy idea that I will tell you about at lunch, that it might be, you know, an aggregate, like you can explain that. I will show you the slides later, but that you can explain, because it has a non-gravitational acceleration, right? So you require a high area to mass ratio. So the idea was that maybe you can have that, provide that high area to mass ratio using like a fractal aggregate, like a giant snowflake. That is something that you actually form in protoplanetary disks. So, but whether.
Whatever it is, it has to be a common process that makes these things, because when Amaya took all the material, the solid materials in all the stars, that's not enough. So it has to be. It cannot be a rare star. It cannot be a rare thing. You know.
And one of the things that was suggested, but it's very ad hoc, right? That is coming from that this thing was fragmented. Also, it was an attempt to explain the unusual size. But that this thing it was coming from a compact system, from an evolved system, and that it was, this thing broke up into many objects of just Oumuamua size, which is very ad hoc, right? Because that will be like it can account for a lot of material. I mean, you wouldn't need that much material because you basically have a peak in the size distribution, right? So, but I think that's quite ad hoc, right?
But it still doesn't solve your orders of magnitude discrepancy, I think, because it doesn't matter what the slope of the mass function is.
Yeah.
Wait, if all objects had the same
No,
form, all the mass.
Yeah.
She can, okay, so she can calculate the mass density per cubic parsec of Oumuamua specifically.
Of just that size.
This is still, I think, about.
An issue. Yeah, that would be interesting to do, but it will be very ad hoc. That we just have to. Yeah.
Maybe it's special size, and there's some process that makes this size.
Well, this was part of the suggestion.
That's why we see
right?
this.
The size of a football field.
Yeah, but then we got Borisov, and that's a kilometer in size. So,
Maybe
and it's giving us the same problem, right? So.
And we also have interstellar dust, right? So there must be.
So it's really interesting, right? Because we were complaining that we had not detected any, and then we finally get one, and I'm like, and now we cannot explain it. Right? It's very interesting. I think it's very interesting.
It's too many.
Now one is too many. That's what I feel like. Now we have one too many. How can that be, right? Yeah. It's very confusing.
There's also the possibility of ejector from a supernova because each supernova has on average a tenth of the solar mass of
material
in dust, and we have no idea what fraction of that.
Yeah. So that's another suggestion. Right.
There's no reason to think that it's a big solid.
Well, right.
Right.
You cannot have it in big chunks because there's not enough time when the supernova ejector expands. At most we can make micron-sized objects, and we see them in 87A, for example. But you can't make bigger things because it expands.
What about the velocities of stars? Like in your assumption, you just assume random velocities, but if there's some, stars that are moving with similar velocities and it's not random, then these chances for encountering grow or not so much?
No.
Doesn't help?
I don't think it helps.
If all the clouds are touching, does that mean there are going to be a lot of encounters where they get tied?
There is a lot of exchange of material between
But I'm just
planetary.
outside.
Yeah, definitely.
Yeah.
That happens all the time.
More than half of
That
those
doesn't help
stars.
you.
So our old cloud cannot be generic to us. It must have been accumulated from countless stars.
But even if you take all the Oort clouds and strip them entirely, it's not enough.
Still not enough.
Yeah.
It's not enough, right? Right.
That's
Because it's
And
at
I am
least a
assuming-
factor of 10, more by
Yeah.
a factor of
We
1,000.
And
need
I am
to-
assuming that all
Okay.
of them have.
So we
Yeah.
need to finish now, but we
Yeah,
can continue
yeah,
the
yeah,
discussion
yeah.
later. Thank you again.
Yes.